Bismillah ar-Rahman ar-Rahim. This is the second tutorial, and over here we have a number of problems in tutorial number 2. Let us look at question number 1. It says that assume that the per unit harmonic current R, so those values are given for the following harmonic order. So 1, 3, 5 up to 25. Also assume that the eddy current loss factor, so we have this is the factor of the eddy current. Determine the K factor of the transformer, and then determine the transformer derating based on the standard. Okay, so we know that the K factor for this transformer, it is given as the summation for the harmonic from 1 until the last harmonic for the harmonic current square time the harmonic order, right? Time the harmonic order square, divide by only the harmonic current, divide by the harmonic current square. So we know all those are given. For example, we have the first harmonic or the fundamental. It is given as 1 per unit. The third given as 0.016 per unit, and so on. So I guess you need to multiply those, square them, and then you multiply them by the harmonic order, and then again divide by the square of the harmonic current, and that will give you K. Part B, he said calculate the derating, the transformer derating based on the standard. So we know that the root mean square current for the derated transformer is given as the square root of 1 plus the eddy current loss factor derating, so B eddy current loss factor, okay, divided by 1 plus the eddy current, and this one will be multiplied also by K. So that will give you the derating based, the transformer derating, since it supply those harmonics. So the result for K will be 5. The result for the derating will be 87%. So the transformer will be derated by 80 or to 87%. Let us now look at question number 2. It says that we have 180 kilovolt ampere shunt capacitor, and this is subjected to third and fifth harmonic. The distortion consists of 4%, so the third harmonic will be 4%, and fifth harmonic will be 3%. Evaluate the capacitor duty requirement. So we like to compare the capacitor requirement with what is specified in IEEE standard 18/2000 limit, and those are the duties. So it includes the peak voltage, root mean square current, kilovolt ampere reactive per use, and root mean square for the voltage. Okay, so the voltage V1, the fundamental component, will be 415. Of course, this one will be the line voltage. So the phase voltage will be that value divided by that value divided by root 3. So that will be the phase voltage, and then we can obtain the third harmonic, which will be 4% from V1, and the fifth harmonic will be 3%. Will be 3% of also the fundamental. So that will be the different harmonics voltage. And now we can calculate the root mean square value for the voltage. So the root mean square value will be given as V1 square plus V3 square plus V5 square. So that will be the root mean square value for the voltage. Okay, now to find the current, to find the root mean square value for the current. Okay, so what we need to do, we need to find the capacitor current. So the capacitor current will be given by voltage, the phase voltage, divided by XC. And of course we can calculate XC if we like, or also what we can do, we can calculate XC directly from the reactive power and from the voltage. Actually also we can do it this way. So the current can be calculated from reactive power, which is 150 kilovolt ampere. So from Q divided by root 3 V line, root 3 time V line, I will call it. Okay, so that will be the current that flow through the capacitor bank. And then we can calculate XC. So from V phase, which is V1, so it will be V phase divided by IC. So that will give you the value of XC. Okay, now we can calculate the current I3, the current that passes through the capacitor due to the third harmonic. So that will be equal to V3 divided by XC over 3. And also we can calculate the fifth harmonic current also from V5 by XC over 5. So that will give you the different current that passes through the capacitor. Then you can find I root mean square from the equation again, from IC or I1 square plus I3 square plus I5 square. Okay, so this is with respect to the value of the root mean square. Now we can calculate also the peak, the maximum peak voltage. So the maximum peak voltage will be given again by V1 peak plus V3 peak plus V5 peak. So it will be V1 peak. So then we have to multiply it by root 2. So V1 peak plus V3 peak plus plus V3 times root 2 plus V5 times root 2. So that will be the peak. And then we can calculate the kilovar produced. So Q will be equal to root 3. Okay, or 3, since this is the phase voltage, it will be 3 V root mean square times I root mean square. So that will give you those duties of the capacitor. And then of course we can compare this value with the with IEEE. Okay, so those are the calculated value for the IC, V phase, XC as we did it, and then we can compare those with what is given in the standard. So those are the standard. Okay, 120 for the peak voltage, whereas over here it is only 107. Root mean square voltage 110, over here 100.1. Root mean square current 135 and 1. So everything are not exceeding the standard. Okay, now with regard to the this question number 3, he said determine the average power supplied by this source if the current that passes through from the source is given as this value. Okay, so of course, I mean, this current will pass through a parallel combination of this resistance and this capacitance. Okay, so that will be the Z, so we can find Z. Then the voltage across Z can be calculated from the current time Z. And then of course you can, so we should not forget that. Over here we have 3 different components. So we have a DC component in which the frequency or omega will be 0. We have another component in which omega will be 1, which is the fundamental, and then we have another component in which omega will be equal to 3, which is the third harmonic. So when we calculate Z, we have to take into consideration those. Okay, so this is the value of Z in general for this 2 branches, that is Z. And then we can find the voltage, current times Z. So of course the current, so as we said, that sometime will be on a DC, sometime it will be on a fundamental, sometime we're gonna have third harmonic, and omega is also changing. So when omega is 0, which is the DC component, we can find the voltage. And when omega 1, again find the voltage. When omega 3, you will find the voltage. You can convert this voltage now from the phasor quantity, magnitude and angle, to time domain. Okay, so it will be the DC component over here for the voltage. As we said, that it will be DC component will be 20. And for the fundamental component, 5 cosine, and the angle is that one. Then over here the angle is minus 44. Now what is the definition of the average power? Average power will be the power that consume an impedance due to the different components. So we have a DC component, which is VDC times IDC. And then we have, let us say, the fundamental component. So it will be V root mean square, I root mean square, cosine the angle between the 2. Of course, this value, it is the peak value over here. So those value will be the peak value of the voltage, and those value are also the peak value for the current. So we should not forget to divide by root 2. So that's why over here we have a half, because we have voltage over root 2, current over root 2. Then cosine the angle between the voltage and the current, and that will give us the power. So the total power, or the average power consumed by the load, will be 41.5. Okay, thank you. That's all.